So today I want us to do some question on matrices and probabilities. So open with me that question. December 2017, question 1D. So we are told that. So Probabilities Limited has a computerized customer billing system. Customer accounts are classified as being paid, delinquent, or bad debt. The company has a total of 1,500 customers accounts. A computer program was developed to display transition of account among the three categories. The output from the program is summarized below. So we have from 2, so that we need to come up with a transition matrix from one state to another. The above transition took place between that 1st December 2015 and that 1st December 2016. Required. The percentage of customer that will be in each of the categories account as at that 1st December 2017. So how do we get the transition in 2017? So to get 2017, you take 2016 times the transition matrix for you to get the composition in 2017. So first of all, I need to get the transition matrix. And how do we get the transition matrix? So we have those deemed to be paid. Also, we have delinquent, and then we had bad debt. So let's add the total for those which are deemed to be paid. We have 285 plus 15 plus 0. Delinquent, we have 20 plus 700 plus 30. Then bad debt, 0 plus 0 plus 450. So this is 450. This is 300. And this is 750. And the total you get 1,500. So can we convert that one into proportion? Let's convert that into percentage. So 300 over 1,500 you get? So 300 over 1,500, this is 0.2. We have it 0.5 and this is 0.3. So now let's convert that into probability transition. So you'll take, let's start for paid. You will take 285 over the total, and the total is 300. Then you take 15 over the total, and the total is 300. And then we have 0 over 300. Then you take 20, you divide by 750. 700 over 750. 30 over 750. 0 over 450. 0 over 450. And then 450 over 450. And that one will be we have it 0.95, 0.05, 0. We have it 0.03. Have it 0.93. Here we have it 0.04. That's 0, 0, 1. So that's our transition matrix. So with the transition matrix, now let's get, we want the proportion in 2017. So how do we get the proportion for 2017? So you take the proportion in 2016, of which we had the proportion here. You'll take 0.2, we had 0.5, and we had 0.3. You multiply by the transition matrix, which you have the transition matrix, 0.95, 0.05, 0, 0.03, 0.93, 0.04, 001. So let's get that. To say that you take the first row, first column, first row, second column, first row, third column. You have it's 0.205. Here we have it 0.475 in rastery. Get it's 0.32. So now we can get, we wanted them in percentage. So the requirement was the percentage of customer that will be paid in each of the categories. So to get that percentage change, we have those deemed to be paid and also bad debt. So here we have it's 0.205, which is equivalent to 20.5%. Delinquent, we have 0.475, approximately 47.5%. And the bad debt is 0.32, which is 32%. So you can take a screenshot of that. So let's try another question. November 2015, question 1A. November 2015, question 5A. Star Manufacturers Limited specializes in the production of two products, A and B. The manufacturer sells the product at a fixed selling price to its customer. The following table shows the requirement for the production of product A and B. So you have product A and B, material in kilograms and labor hours, and then we have the available resources. Product A is sold for shillings 2080 per unit, whereas product B is sold for 79.39 per unit. The variable costs of production are uncertain with the following margin of errors. So we have the labor per hour for both A and B, material per kilogram for each product, and then you are given the error. For labor hours can increase or decrease by 10%, but for material it's by increase or decrease by 5%. Star Manufacturers Limited utilizes all the available resources required. Using matrix algebra, determine, number one, the total expected revenue. So number one is to get total expected revenue. So use the matrix algebra. So we are given the usage. Let's start with material. You require 5 units of A, plus you require 7 kilograms to make each unit of B. And the total available hours we have is 13,400. But for labor hours, you require 3 hours to make A, plus 4 hours to make each unit of B. And the total available hours we have is 78. Then from there, you convert that one into matrix. So you take 5, 3, 7, 4, A, B is equals to 13,400, 7,800. So in this case, we need to get A and B. So to get A and B, you divide both sides by this matrix. So if this goes to the other side by a division, you show it at inverse, as inverse 5, 3, 7, 4. We said division means inverse. Then we have 13,4, 78. So how do we get A and B? So first of all, we get the inverse. We said that to get the inverse, first of all, we need to get the determinant. And to get the determinant, you take the major diagonal, 5 times 4, you get 20, minus minor diagonal element, 3 times 7, you get 21. So 20 minus 21, you get -1. That's the determinant. Once you get the determinant, you reciprocate the determinant. So it will be 1 divided by -1. Then we see that for the major diagonal element, you interchange. 4 goes there, 5 goes there. But for the minor diagonal, you change the sign. -7, -3. And then we have 13,400, 7,800. So what do we have? First row, first column, then you divide by -1. So you'll take 4, you multiply by 13,400, you add -7, you multiply by 78, then you divide by -1. You get 1,000. So to get for B, you take -3, you multiply by 13,400, then you add 5, multiply by 7,800, and then what you get, you divide by -1. And you get 12. So that means your production, A, you produce 1,000 units with the available resources, but product B, you produce 1,200 units. But the question, they wanted the total revenue. So to get the total revenue, A, you are producing 1,000 units. And how much was the selling price per unit? You are told that product A is sold for 2080. And then B, we produce 1,200 units. And the selling price per unit of B is 79.39. So what do you get? You'll get 11,606,800. Number two, the expected maximum profit. So how do we get the maximum profit? So to get the maximum profit, you take maximum revenue minus minimum cost. That's how you get your maximum profit. Take the maximum revenue minus minimum cost. So we have product A, we have product B. First of all, get the maximum revenue. Product A, we are producing 1,000 units, each at a selling price of 2080. Product B, we are producing 1,200 units, each at a selling price of 79.39. That's how you get the maximum revenue. Then you deduct the minimum cost. And how do we get the minimum cost? So we are given the price per limiting factor, that's per labor hour, and then for material kilograms, and then you are given the margin of error. So let's start with product A. Product A. Product A, for you to make 1 unit of product A, you require labor hours, as well as you require material. And how much is the price per labor hour? For 1 labor hour, for A, it costs 140. You multiply by the margin of error. In this case, we're looking at the minimum cost. So minimum cost, that means the price will go down or will go up. The price will go up. Will go down, I mean, for the minimum cost. And the margin of error is 10%. So it's 140 multiplied by 90%. But 140, the 140 shillings, it's per hour. That's what we're told. It's labor per hour. It's 140. How many hours do we require to make each unit of A? How many labor hours? We require 3. Plus, we are looking at A. A also require material. And how much is material cost per kilogram? Material cost per kilogram is 230. 236. Then the margin of error for material can increase or decrease by 5%. In this case, we're looking at the minimum cost, so we expect it to go down by 5%. So you multiply by 95. But 236, that was the amount, that's material per kilogram. How many kilograms do you require to make each unit of A? You require 5 kilograms. Now, what you get here, this is for 1 unit. But the production, A, we are producing how many units? We are producing 1,000 units. Let's go to B, we do the same. B, let's start with the labor. Labor cost for B is 265. Then we expect it to go down by 10%. So you multiply by 90%. How many hours do we require to make each unit of B? How many hours do we require to make each unit of B? 4. You add. Now we go to material cost. Material cost for B, it's 710. But material cost can increase or decrease by 5%. So for the minimum cost, we expect it to decrease. So we multiply by 95%. How many kilograms do you require to make each unit of product B? Is it 7? 7. So what you get here is the cost, that's the material and the labor cost per 1 unit. And how many units are we producing? For B, we are producing 1,200 units. So let's get the maximum profit. We have 581,000. I'll get 27, 16, 200, if I'm not wrong. So that means the total will be that's what you get. Let's answer number 3. Number 3. Number 3 is expected minimum profit. So how do we get the minimum profit? So to get the minimum profit, you take maximum, or you just take the revenue minus maximum cost. In this case, you expect the cost to go up. That's how you get the minimum profit. You take the revenue, you deduct the maximum cost, and it will be the same. A, B, the revenue does not change. A, we are selling 1,000 units, each at 2080. B, we are selling 1,200 units, each at 79.39. Then you deduct the cost. So for A, it's 140, but to get the maximum cost, you expect it to increase by 10%. So instead of multiplying by 90%, you multiply by 110%, and to make 1 unit you require 3 plus 236, that's the material cost. Material cost will increase or decrease by 5%, so expected to rise by 5%. So you multiply by 105%, and you required 5 kilograms. So you get the cost to make 1 unit. But the production for A, we are producing 1,000 units. For B, it will be the same. You take 265, you multiply by 110, you multiply by 4, plus, for material cost, the price is 710, then you expect it to rise by 5%, so you multiply by 105%. To make 1 unit, you require 7 kilograms. So you get the cost per 1 unit. And the production for B, you're producing 1,200 units. So what do you get? You get 379,000. Yeah, you get is 18,65,400. Then you add the total. So you can take a screenshot of that. So you can try another question. November 2019, question 1C. November 2019, question 1C. So part C, I told that a small economy has two sectors, X1 and X2, producing a single product for their internal and external demand in units are summarized in the following matrix. So we're given the production sector and the purchase sector. So that's what we call Leontief analysis or output input analysis. And then you're given the customer demand. So the customer demand is equivalent to what we call the final demand. And then the production and the purchase sector movement is what we call the intermediate demand. The projected consumer demand changes to 400 units and 800 units for sector X1 and X2 respectively. Required, the required gross output for each sector in order to meet the new demand, the gross output. So we say that, how do we get the total output? We say that to get the total demand or output, you take the intermediate intermediate demand, you add the final demand. So, of which we say that to get X, which is represented by the total demand, you take that, what you call technological coefficient matrix, then you compute its inverse, then you multiply by D. So first of all, we need to get what we call the technological matrix. That's A. Technological matrix, which is always denoted by A. And how do we get the technological matrix? We say that to get the total demand, you take the intermediate demand, you add the final demand. And we have for sector X1, X2. X1, you take 500 plus 800. And then you add the consumer demand. The consumer demand represents the total or the final demand of 200, of which you get 1500. Then for X2, X1 is 600 plus from X2 is 1400. You get the intermediate demand. Then you add 400, the final demand. So that is 2400. So how do you convert that into a technological matrix? So this is how you convert that. You take 500, that's for X1, X1. You divide by the total demand, which is 15. In this case, you apply it vertically. Then you take 600, you still divide by 1500. You don't add it horizontally. Then X2, you will be taking 800. You divide by the total of X2, which is 2400. And then you also have 14. You divide by the total demand for X2, which is 24. And to get a technological coefficient, we have it's 0.33. Have it 0.4. So we have 0.33. We have it's 0.58. So that's our A, the technological coefficient matrix. So let's get the relative matrix. And how do we get the relative matrix? To get the relative matrix, you take the identity matrix minus technological matrix. So, and in this case, is a 2 by 2 matrix. Therefore, identity matrix will be 1, 0, 0, 1. You deduct A, our technological coefficient matrix, 0.33, 0.33, 0.4, 0.58. So you take 1 minus 0.33, get 0.67. 0 minus 0.33, get negative 0.33. 0 minus 0.4, get negative 0.4. And then 1 minus 0.58, get 0.42, right? So that's what we call the relative matrix. Once you get the relative matrix, we need to get its inverse. We get what we call the relative inverse. So relative inverse, so you just take its identity matrix minus A, then you get the inverse, of which we had that. Our technological coefficient in that case is 0.67. Then we have negative 0.33, 0.4. We have 0.42. We get the inverse. So how do we get the inverse? Over 2 by 2 matrix. First of all, you get the determinant. And to get the determinant, we say that you take the major diagonal element, that is 0.67, you multiply by 0.42. Then you deduct the minor diagonal, negative 0.4, multiplied by negative 0.33. What do we get? get 0.15 or 0.1494. Therefore, it will be, now to get our X, we have said that to get X, you take technological or Leontief inverse multiplied by D. So it will be, how do we get this, the inverse? So we already have the determinant, so it will be, the second step, we will reciprocate the determinant, 1 divided by 0.15. Then we say that for the major diagonal, you interchange 0.42, 0.67. For the minor diagonal, we change the sign, so it will be 0.33, 0.4. You multiply by D. In that case, let's go to the required. Required, we are told that the required gross output, okay, before the required, we are told that the projected consumer demand, that's the final demand, changes to 400 units and 800 units for sector X1 and X2. So we expect 400 and 800. So how much is the gross output? So you take 0.42, multiply by 400, you add 0.33, multiply by 800, then what you get, you divide by 0.15. You get 2880. As for X1, what about X2? Get 4640 for X2. So that's how we get the gross output. So you can take a screenshot. So take out your handout. Handout page 2, question 4. Handout page 2, question 4. The manufacturer of Tamu soft drink have been facing stiff competition on its main brand, Tamu Cola Soda. The management is considering an extensive advertisement and rebranding campaign. If the current branding remains, the transition matrix of the consumer between Tamu Cola and other brands will be as follows. You're given that matrix. After advertising and rebranding campaign, the transition matrix is expected to change as follows. Then you're given the transition matrix after the advertising and rebranding campaign. The advertising and rebranding campaign is expected to cost 20 million each year. There are 40 million consumers of soft drinks in the market, and for each consumer, the average profitability is Sh5 annually. Required, number A, the equilibrium state proportion of Tamu Cola Soda before the advertising campaign, the equilibrium or long run. So we are looking at the equilibrium before advertising. So we wrote for advertising, we need to compute the equilibrium state. And we say that equilibrium, the current state times transition matrix, you'll go to the future state, of which the future state equivalent to what? To the current state. That means, in short, the current state is always equal to the future state. That means the transition matrix has no effect. So we can say that let term Cora, we have term Cora and we have others. So let it be X, let it be Y. So that means if you take X and Y as the proportion, that's the current state, you multiply by the transition matrix, you go to the future state, which is the same as the current state, you also get X and Y. But we say that if you take the proportion of X plus proportion of Y, you should get 1. So if you get X, how can you get Y? It's the same as 1 minus what? X times the transition matrix, and you go to the future state, which will be equivalent to the current state, X 1 minus X. So it will take X 1 minus X. Give me the transition matrix before the advertisement. Before the advertisement, we had 0.85, 0.15, 0.25, 0.75, and you should get the current state should be equal to X 1 minus X. First row, first column, so we'll be taking X, you multiply by 0.85 and you get 0.85X plus 1 minus X, you multiply by 0.25, you'll get 0.25 minus 0.25X. First row, first column, you should get X. So, and that one is equals to X. So with that, let's bring the right term together. You take 0.5X minus 0.25X minus 1. If you take this to the other side, what do you get? You get negative 0.4x is equals to, so take this to the other side, is equals to negative 0.25. Therefore, can we get x? So x is equivalent to 0.625. Therefore, y, I say that to get y, it's 1 minus x. Y will be only be controlling 0.375. Let's go to part B. Part B is the equilibrium state proportions of Tamukora soda after advertising campaign. So after advertising. So after advertising, you'll be taking x to get y, it's 1 minus x times the transition matrix, of which you should get x 1 minus x. So take x 1 minus x, you multiply by the transition matrix after the advertising. And you're given the transition matrix after advertising. You're having 0.9, 0.1, 0.3, 0.7, and should be equal to x 1 minus x. First row, first column. So you take x times 0.9, you get 0.9x plus 1 minus x times 0.3, you get 0.3 minus 0.3x. And first row, first column, you should get x. So let's bring the right term together. 0.9x minus 0.3x, you get 0.6x, then you minus 1. You will get negative 0.4x is equivalent to, you take this to the other side, negative 0.3. Therefore, x is 3 over 4. That is 0.75. Therefore, to get y is 1 minus x, you get 0.25. So what you can observe is that before the advertisement, X, which represents the term Cora soda, was controlling 62.5%. But after advertising, X now will be controlling 75%. 75%. Number C. The expected annual profit increase or decrease after the advertising campaign. The profit increase or decrease after the advertising. So now let's look at the cost before advertising. Cost before advertising. We compare against the cost after advertising. And that's how now we determine the increase or the decrease. So the cost before advertising or the profit, they're asking about the expected annual profit, sorry, is the profit before and the profit after. So before the advertising, Tamukora was controlling a proportion of how much? Before advertising X, we are controlling a proportion of 0.625, but after advertising, we'll be controlling 0.75 of the market. Now, in the question, we are told that the advertising and rebranding campaign is expected to cost 20 million each year. There are 40 million consumers. So that means before the advertising, if we have 40 million consumers, the number of customers is not changing. What is changing is the proportion. So we are controlling 62%, 62.5% of 40. Then you are told that, and for each customer, the average profitability is shillings 5 annually. So you take 62% of 62.5% of 40 to get the number of customers, then you multiply by the average profit per customer. What do you get? Multiply by 40, you multiply by, and you get 125 million. After advertisement, the proportion has risen to 0.75. You multiply by 40, you multiply by the profit per client, then you deduct. We have the cost we have to incur for us to advertise. A cost of how much? 20 million. So 0.75, you multiply by the number of customers, then the profit per customer, and you'll get 130. So before the advertisement, the profit was 125. After the advertisement is 130. So there is a profit increase of 5. So you take 130 million minus 125 million. There's a profit increment of 5 million. So that means you can recommend that they should conduct an advertisement. You can take a screenshot of that. So I think now you're somewhere with the matrices. So now we can look 1 or 2 questions on probabilities. So open with me May 2016, question 2, 2B. May 2016, question 2B. Now, part A of the question, you are told that distinguish between univariate function and multivariate function. And you see that univariate function is a function with only one. That means uni, only one independent variable. But a multivariate function is a function with at least two. It has at least two independent variables. Now let's go to part B. So that's something you have in your notes. Part B, I told that the mean weight of 500 packaging tins from the production process are normally distributed with a mean weight of 151 grams and a standard deviation of 15. So you're told they are normally distributed. So when you're told that they are normally distributed, that means they follows a normal distribution. Therefore, with normal distribution, you need to get the X bar, the mean, and then we need to get the standard deviation. And we are told that is normally distributed with a mean weight of 151 grams and a standard deviation of 15. So standard deviation is 15. Required. The number of packaging tins that weigh between 120 and 155. That weigh between 120. So where does 120 falls? Tries on this side, 120 and 155. So 155 is somewhere there. So we want the number of packaging tins. So first of all, you need to get the probability that lies in between 120 and 155. And how do we get Z? Z is x1 minus x bar over standard deviation. But in this case, we have to compute two Z's. So the first one, x1, you take 120, you minus the x bar, which is 151, over the standard deviation of 15. Then to get Z2, your x1 in this case will be now 155 minus x bar of 151 over the standard deviation of 15. We see that for the normal distribution, you ignore the negative. And then your answer should be into two decimal places. Here you get is 2.07. You get it's 0.27. Now let's get the probability. We read it from the table. Let's go to the normal distribution table. A normal distribution table. We look at that probability from the table. 2.07. 2.07. We get 0.4808. What about 0.27? 0.27. 0.10554. Good. So what we got, the first one we got is between the probability between 120 and 151. It's that. Then the second one is between 151 and 155. So to get the combined probability, you just sum up the two probabilities. So, and what do you get? And the probability of lying in between 120 and 155 is 0.5862. That's the probability. But we are looking for number of tins. That was the question. You are not asked about the probability. Is the number of packaging tin that weigh in between that. So you'll take the probability of 0.5862. And we had how many number of tins? 500 packaging tins. You get approximately 293 tins. Number two. The number of packaging tins that weigh more than 185. So let's draw that. Our X bar does not change, is 151. Standard deviation is 15. In this case, we are looking at the number of packaging tins that weigh more than 185. 185 is on this side, 185 more than. So we are looking at that shaded part. So to get Z, we're saying it's X1 minus X bar over standard deviation. X1 in this case is 185 minus X bar of 151 over the standard deviation of 15. you get 2.27. 2.27. Now let's do that from the table. 2.27. Get 0.4884. That's 2.27. 4884. Good. So now with that, that's the probability between 151 and 185. That's not what we need. So we know very well that all this probability is 0.5. So to get that probability, you take 0.5. You eliminate the probability of between 151 to 185 so that we get greater than 85. You deduct 0.4884. So 0.5 minus 0.4884. You get a probability of 0.0116. So to get the number of teams, you take 0.0116, you multiply by 500 to get approximately 6 teams. 6 teams. Good. So before you take a screenshot, we can still do another question. September 2015. September 2015, question 5A. So we are told that a machine is composed of 3 components, X, Y, and Z. The probability that X is in good working condition is 7/10. If component X is in good working condition, the probability that component Y is in good working condition is 3/5. That's what we call conditional probabilities. Then if component X is in good working condition, the probability that component Y is in good working condition is a third. If component X and Y are in good working condition, the probability that component C, so I want you to change that. The probability of component Z, right? Z, it's not C. The probability of component Z is in good working condition is 5/6. Otherwise, it's 1/10. The machine can only be effective when component Z is in good working condition. Record the probability that the machine is effective. So if you see a conditional probability, what comes to your mind? I showed you on how to draw the decision tree for conditional probabilities. So in this case, how many components do we have? We have 3 components, X, Y, and Z. That we are told that the probability that component X is in good working condition. So this component X can be in good working condition, all others not in good working condition. Then you go to Y. Y is in good condition or not in good working condition. The same here. Y or is not in good working condition. And then we have what? Z. Or it's not in good working condition. Z not in good working condition. That's how you draw conditional decision tree. So now let's read the question again. A machine is composed of 3 components, X, Y, and Z. The probability that component X is in good working condition is 7/10. Being in good working condition, it's 7/. That means not being in good working condition is 3/10. If component X is in good working condition, so if component X is in good working condition, The probability that component Y is in good working condition is 3 over. If X is in good working condition, therefore the probability of component Y being in good working condition is 3 over. That means Y not being in good condition is 2 over 5. If component X is not in good working condition, the probability that component Y is in good working condition is a third. If component X is not in good working condition, probability that Y will be in good working condition is a third. Therefore, not being in good working condition is 2/3. If component X and Y are in good working condition, the probability of component C is in good working condition is 5 over 6. If component X and Y are in good working condition, therefore probability of Z being in good working condition is 5 over 6. Therefore, this will be 1 over 6. Otherwise, it's 1 over 10. Can you do the last statement again? If component X and Y are in good working condition, the probability that component C is in good working condition is 5 over 6. Otherwise, it is 1 over. What does it mean by otherwise? If X and Y or X or Y are not in good working condition. So if X is in good working condition, but Y is not in good working condition, probability of Z being in good working condition is 1 over 10. Also, this one will be 9 over 10. If component X is not in good working condition, but Y is in good working condition, still probability of component Z being in good working condition is 1 over 10. Therefore, this one will be 9 over. If also X is not in good working condition or Y is not in good working condition, probability of Z being in good working condition is 1 over 10 or 9 over 10. Now let's answer the question. Required, number 1. The probability that the machine is effective. Effective, that means that all the components are in good working condition, that X is in good working condition, Y and Z. So you'll take 7 over 10, and also Y being in good working condition is 3 over 5, and Z being in good working condition is 5 over 6. And then you convert that into probability. Number 2, the probability that only component Y or Z is in good working condition, X or Y. Sorry, Y or Z. Yeah, Y or Z. So that means Y or what? So what's the probability that Y is in good working condition? If only Y is in good working condition, that means both X and Z are not in good working condition, that Y or Z. So that means in that case, X is not in good working condition, or what's the probability of X not being in good working condition? It's 3 over 10. Y being in good working condition when X is not in good working condition is 1 over 3, and Z is not in good working condition. It's only 1. It's either X or Y, not X, not Y and Z, but Y or Z. So it's 9 over 10. Or we are told that Y or Z. So can we get the probability of Z being in good working condition? What does that mean? If it's only Z which is in good working condition, that means X was not in good working condition. Also, Y is not in good working condition, but Z turns out to be in good working condition. Then you get the probability of the two. Then you sum up. We say that OR means you do what? You add. Good. And lastly, number 3. The probability that component Y is in good working condition, given that component Z is in good working condition. I need to try to interpret that. That's very easy. The probability that component Y is in good working condition, given that Z is in good working condition. In short, it's asking probability of both Y and Z being in good working condition. Y and Z. So if Y and Z are in good working condition, that means X was not in good working. So X is not in good working condition. So you take 3 over 10, but Y is in good working condition as well as Z is in good working condition. and you get your probability. So you can take a screenshot now. So open with me June 2009, question 2. June 2009, question 2. For those without that question paper, I had shared it to the WhatsApp group. I hope now you have already have it. You already have it. June 2009, question 2. Part B, June 2009, question 2, part B. So part B, I told that BD Enterprise, a small size firm, has been contracted to produce metal bolts by a contractor. In order for bolt to match the quality decided by the contractor, the bolt must have a minimum length of 100 millimeter, a minimum length of 100 millimeters, and a maximum length of 105 millimeter, a maximum of 105 millimeters. So it should be within 100. That's the minimum and the maximum of 105. Any bolts below 100 millimeters in length is regarded as spoiled. Anything below 100 will be regarded as spoiled. While those longer than 105 millimeter in size, in length, are cut to size. Those longer than 105, greater than 105, will be cut to size. And you are told that. So that means anything now between 100 and 105, that's when you get what we call usable without modification, or without cutting. Then you are told that if it costs 100 to produce a bolt and a further 80 to cut it bolt to size, if the length of the bolt is greater than 105 millimeter. So you're told that to produce one bolt is 100, and further will incur an additional 80 to cut a bolt to size if their length is greater than 105 millimeter. A batch of bolt produced by the firm had a mean of 1 or 2 millimeter with a standard deviation of 2 millimeter. Had a mean. So mean is our X bar, which was 1 or 2, and a standard deviation of 2 millimeters. Note, assume the production of bolt is normally distributed. Required, the percentage of bolt that were less than 100 millimeter in length, less than. So the first one, we get the one with less than 100 millimeters. So to get Z, you take X1 minus X bar over standard division. So in this case, our x1 is 100 minus x bar 102 over standard deviation of 2. 2 over 2 you get 1, but should be into 2 decimal places. So it's 1.00. We say that always ignore the negative. So can we read this inside the table? Give me that probability. From the table, sorry, from the table, 1.00, you get 0.34. 13. Is that what you're getting? Therefore, the probability of being less than 100, it will be, now what you have gotten 0.3413 is a probability between 100 and 102. So you'll be taking 0.5, you deduct 0.3413. So probability of having less than 100 millimeters, 0.5, you deduct 0.3413. You get 0.1587. So now let's number two. The percentage of bolts produced that were more than 105 millimeter in length. So number 2, those will more than 105. The one which will be regarded to cutting to size. So Z is equals to X1 minus X bar over standard deviation. X1 in this case will be 105. X bar does not change, is 102. Then you divide by the standard deviation of 2. 3 over 2, you get what? 1.50. So give me that probability from the table. 1.50. You get 0.4332. But that's not the probability of being greater than 105. So to get its actual probability, remember what we have gotten here is between 102 and 105. So greater than 105, you'll take 0.5, you deduct 0.4332. You get a probability of 0.0668, right? Yes. So I think we have analyzed that. So now let me give you a summary here. I just want to give you a summary. Probability of those which are spoiled. Those were the one with less than 100. And we have gotten a probability of 0.1587. That's a probability of both being less than 100, of which we are told that will be regarded as spoiled. Now, probability of those which are deemed to be cut to size. Cut to size are the one which have a mean length of greater than 105, and we have gotten a probability of 0.0668. Now, can we be able now to get the probability of those between 100 and 105? Probability of those between 100 and 105, which are deemed usable without any cutting. So we have the two probabilities. We had probability between 100 and 102. And the probability is what we had computed here. The probability was 0.3413. So you take 0.3413. That's between 100 and 102. Then also you add the probability of between 102 and 105. And when you're computing more than 105, you compute that probability between 105 and 102, of which we got 0.4332. So give me that probability. 3413, 1.4332. And that probability is 0.7745. Now let's go to part C of the question. Part 3 of the question, we are told that the expected cost of producing 10,000 usable bolt. Expected cost of producing 1,000 or 10,000 usable bolt. So number one, you have to get the probability of producing the usable bolt. What's that probability? probability of usable bolts. That means for those spoiled are not usable altogether. But for those to be cut to size, they are usable with some modification. So it will take 0.0668. Those greater than 105, they are usable, but it will be deemed to be cut to size, plus those usable without any modification. And we have computed the probability, which is 0.7745. So give me the probability of producing usable bolts. 6. Did you get 0.8413? So that's the probability of producing usable bolt. So now can you read the question again? The question was, the expected cost of producing 10,000 usable bolts. Okay. So if this is the probability of producing the usable, so you'll say that 0.8413 is equivalent to 10,000. What about 1? Now, if this is the probability of producing, now let me tell you one thing. If we produce 10,000 usable, that means the production was more than that because we had some units or some bolts which will be regarded as what? Spoiled. Regardless whether they are spoiled or not spoiled, the cost of production is 100. Are you together? We'll have to incur that cost. So that means for us to produce 10,000 usable bolts, of which the probability is 0.8413, we must produce more than 10,000. So that means how much is the production, the total production, including those which will be regarded as spoiled. So you'll take 10,000 divided by 0.8413. And that means you have to produce 11,886 bolts. Yes. For you to get 10,000 usable bolts, the total production cost should be 11,886 bolt. So now let's get the cost. The cost of production, you have to produce 11,886. Regardless whether they are spoiled or not spoiled, the production cost per bolt is how much? Yeah, it costs 100 to produce a bolt. So you multiply by 100. So that means the total cost is how much? The total cost will be 11,886.00, and then you add cost of cutting. Cost of cutting. My question is, how many bolts will be added to cutting? It's very simple. So you have the probability of those deemed to be cut to size. And those deemed to cut to size, the probability is 0.0668. So you'll take 0.0668. You multiply by the number of bolts produced, which was 11,886. And then to cut each bolt, it is costing us how much? 80. Yeah. So the total production was 11,886. You multiply the probability of those bolts greater than 105, which will be deemed to be cut to size, is 0.0668, so that you get the number of bolts deemed to be cut to size. Then you multiply by, to cut each unit, it will cost you 80 shillings. Therefore, incurring an addition of 63,519 shillings. So how much will be the total cost? 118. Total cost will be 12,52,119. So that's how you're getting your 6 marks. It's all about interpretation. You cannot work with just 10,000 usable. Number 4. Number 4. Number 4, you are told that you explain the implication of cost if the mean length of bolt produced increased to 102.5. Explain the cost implication. So what will happen if our mean changes from 102 to 102.5? So that means in this case, our mean increases to 102.5. But those less than 100, nothing has been touched. That one we have to be regarded as what? Spoiled. And those greater than 105 will be cut to size. So let's compute this probability. So probability of less than those deemed to be spoiled, less than 100. So you take Z is equals to X1 minus X bar of a standard deviation. X1 will be 100. X bar now changes to 102.5. Standard deviation does not change, which was 2. So let's get that. You get 1.25. So let's get that probability. Let's get that probability. 1.25. 1.25. 0.3944. 0.944. But that's a probability between 100 and 102. We want the probability of those regarded as spoiled. So you'll take 0.5 minus 0.3944. And you get 0.1. 10. Z56. Then we get those greater than 105, those greater than 105. So it will take 105 minus X bar, which is 102.5 over standard deviation of 2. Z0 1.25? 105 minus 102.5 divided by 2, you still get 1.25. We read it from the table, you still get 0.3944. But that is the probability now between 102 and 105. So can we get the probability of greater than 105? So you'll take 0.5 minus 0.3944, of which you still get 0.1056. Now let's get the probability of having those usable between 100 and 105. Those are regarded usable without cutting. So just add the two probabilities. And probability between 100 and 102.5, we have computed it's 0.3944. Then you have the probability between 102.5 to 105, 102 to 105. See, the probability is the same? Is the same at 0.3944. What's that probability? 0.39944. You get 0.7888. Are you together? So we are looking at the cost implication. So what will happen? What will happen? So we want to get the probability of usable bolts. Probability of usable bolts. So you'll take those regarded as spoiled, just eliminate that. So you'll take those greater than 105 plus those between 100 and 105. So you'll take 0.7888. That's the probability of being between 100 and 105. Then those deemed to be cut to size, they are also usable, but subject to cutting. So you add probability of those being cut to size, and we have the probability of 0.1056. What's the probability? .8944. So now, what's the cost of producing 10,000 usable bolts? So this is how you argue. If this probability of producing usable bolt 0.8944 is equivalent to 10,000. What about probability of 100%? 1, that means we have to produce more than that unit. So, and the production should be equal to, we have to produce 11 181 volts. Therefore, how much will be our cost? It's 11 181 volts, each at a production cost of how much? Hey, how much is the production cost? 100 plus we have those deemed to be cut to size. So of the total production, 11 181 volts, we have those deemed to be cut to size. And what's the probability of those being cut to size? The probability was 0.1056. You get the number of bolts. And then the cutting cost is how much per unit? 80. So it's 11 181 bolts. Probability of those being cut to size is 1056. And you get 1180 bolts to be cut to size. And the cutting cost per unit per bolt is 80. Then you add 11181 multiplied by 100. And the total cost will be 557. Now, what is the cost implication? Can you compare the cost when the mean was 102? The cost was 1252. But after the mean has increased to 102.5, we have 12. So the cost has done what? The cost has reduced. You get your 20 marks. Good, and that marks the end of that session.